Greetings and good day. My name is Darrell Jordan-Smith. I'm the Senior Vice President of Industries and Global Accounts here at Red Hat. It's an absolute privilege to have the opportunity today to walk you through how we're seeing this market evolve and what the opportunities are before us and how that all comes together with this new and evolving technology called Open RAN. So first of all, let's look at the market overall. As you can see from the left-hand part of this slide, you have a non-standalone 5G environment that's typically running on existing 4G based infrastructure, and you have standalone environment, which is sort of a brand new greenfield based environment running 5G. We're seeing ORAN actually, or Open RAN, actually starting to grow, as you see with the standalone area of the network in the marketplace. We see that as a great opportunity, a great focal area for ORAN overall. And on the right hand side here, you see the overall growth in terms of market opportunity. Between now and 2024, the market is actually estimating the size of the ORAN market to be about $3.2 billion, but some very aggressive growth, as you can see overall in the marketplace. So we're seeing this as a very interesting area, and it's actually being seeded by some premier operators around the world. So companies like Orange, Telefonica, Vodafone, and Telecom Italia have stated that they are actually going to production-based ORAN deployments by the end of 2022, and that's really significant from a commercial perspective because it's seeding the marketplace. It's actually enabling companies to actually invest, build products and solutions, do the integration to do that. And the reason why the operators are really focusing in this area is because ORAN drives up innovation. And when you have increased innovation and you disaggregate the network infrastructure, you open different interfaces, which I'll talk about in a minute, you actually lower the cost. And at the same time, you're increasing the overall choice that you actually have in the marketplace. So you can actually leverage a multitude of different vendors and ecosystems to actually execute more holistically in this particular space. So it's a particularly exciting environment. And as I was just saying, this is all about RAN decentralization and RAN cloudification. So centralization is around the disaggregation of software and hardware, so you can split the functionality and the baseband technology that goes into the tower, and you can actually move it to the cloud, again separating hardware and software to drive some economics around telco-based, cloud-based implementations. And it's really underpinned by open standards and open source technology. And it's not just open source, but it's we're seeing those two areas coming together and working together to again fuel innovation, fuel use cases, fuel opportunities to deliver net new services, which then drive the business case to move to a standalone 5G based environment more attractive for the operators. So as this slide talks to the fact that the Telecommunications Infrastructure Project, also called TIP, they're really focusing on hardware and open compute based platforms and certification. ORAN is really focusing on those open interfaces and opening those up in order to fuel and drive that disaggregation and the separation of hardware and software. So this is a very, very dynamic space, requires a significant amount of integration, but we're confident, as what we're seeing through the initial proof of concepts and pilots that we've been involved in, this is actually gaining momentum. And as we move forward in a little bit more detail, where we talk about the front haul network itself and the interfaces, the 3GPP interfaces that are defined, you see sort of three layers here, three different implementations of RAN. One is talking about ORAN itself, as an appliance. So if you were to build an appliance, put a lot of their software on bare metal to enable the radio unit, the ORU as it's called, or the distributed unit, the open distributed unit, and the interfaces talking to the central unit in the overall topology of a 4 or 5G based core environment. This is often referred to Open RAN from an appliance perspective. It's also important because a lot of people get confused between what is ORAN, what is vRAN, what is CRAN. There's a lot of nomenclature around here, and I wanted just to spend a moment talking about what is the virtualized RAN. It's really basically closed interfaces running on a cloud-based platform, either in VMs or containers, that enables you to deploy a virtual-based RAN environment. It is not open, so you don't necessarily have the benefits of the disaggregation of hardware and software that I was talking about on the previous slide. And then if you combine Open RAN and vRAN, you actually get the best of both worlds. You get the virtualization in the cloud platform layer, and you get the disaggregation of the front haul and the actual interfaces as defined by 3GPP. So it enables you to choose your vendor of choice from software, your vendor of choice from hardware, leverage the innovation that hardware acceleration will afford as we move forward in this particular space in order to open up new opportunities, new services that will help monetize the investment overall, which is really driving how we're moving forward in this industry and in this particular topic overall. Then, as I mentioned or hinted to on the previous slide, it's also important to understand that there is a lot of work to be done that has been done around performance. And in this slide, I talk a little bit about the importance of low latency, deterministic low latency. I talk about protocols that need to be developed, so handoff from one cell to the other in terms of precision time protocol are particularly important. All the hardware acceleration around FPGAs, smart NICs are also key in this area, where there's a lot of integration and work and driving a lot of that in order to get the tuning of the environment. You need to manage a very complex set of CPUs in the environment in the context of RAN itself. You've then got to look at the overall topology and how you manage that and the different footprints depending on the landscape and topology you might look to deploy. So you can imagine or visualize a very rural area compared to a very built-up area, managing that topology, driving such resources and making them available to the software layer from the hardware layer that allows you to do specific CPU pinning, look at optimizing input-output functions in terms of what you're trying to drive in terms of the network functions themselves, and in order to then manage that in order to give predictability and through a quality of service experience. And then obviously low latency is going to be really key for 5G based deployments and some of those new applications and service scenarios that we see evolving in this space. Then the other important thing in this environment, because of the dynamics of delivering very large amounts of cellular equipment across those different topologies, as we talked about, we've always got to be in a situation where we can reduce the footprint. Obviously, power is very important in some of these remote locations. Having choices in terms of hardware that you might want to deploy in those environments, and also being able to retire it and replace it without having to rip and replace absolutely everything, because you've got confidence through open standards and open source that these elements are actually able to integrate with each other and give you that degree of flexibility and allow you to innovate with your vendors of choice in terms of hardware and software and those elements. We also see in terms of zero-touch provisioning is particularly important. Automation at scale is critical in this environment, because we're not talking a couple of thousand nodes, we're talking hundreds of thousands of nodes in terms of actual deployments. And therefore, the ability to be able to manage that is also particularly key. And we're seeing a lot of work go into this area, into these commercial deployments by next year, by the end of next year, that enables all of these components to come together. And with that, there are a number of ecosystem partners here that everyone needs to be aware of. And I've named them alphabetically. I didn't really want to sort of layer them by type. They're just layered alphabetically in terms of all these different partners. Certainly from a Red Hat perspective we're working with, but many other companies are also working with, from a firm networks all the way through down into Samsung with hardware acceleration and special drivers with Intel and NVIDIA. Really exciting area for innovation. The other important part here is to know that in a cloud, you actually have to integrate different components or different cloud native applications and services in order to build the carrier grade capabilities needed to sustain a live network implementation. So integrating, partnering, certifying, understanding the life cycle in all of those elements. All of that testing needs to occur. And in many instances, we're seeing a different ecosystem of integrators coming to the forefront as well. Companies like Infosys or Tech Mahindra or Tata, for just a few examples of big integrators looking at this particular market and space to integrate cloud native based applications, not just from a RAM perspective, but how it's operated, how you manage all the business support systems associated with that, whether you actually put those in your own telco cloud-based environment, or you might want to put them in a managed public cloud instance. So these are really exciting areas of innovation which actually further lower the cost, increase the agility, deliver new services actually into the marketplace. And from a scale perspective, that's very, very important. It's all around zero touch. And my last slide really is to talk a little bit about, so where's Red Hat in all of this? So 2 years ago, before ORAN actually was formalized, I think the first meeting was in Santa Clara, actually in, if I remember correctly, 2017, where some of these concepts were first discussed, to where we are today in terms of actually getting the pilots and proofs of concepts deployed in real operators to get to a commercial deployment in 2022. Red Hat has been really focused on developing a cloud-based platform. We call it OpenShift, which is scalable in a private instance, in a private cloud, as well as in a public cloud instance, as well as actually developing all of the features and capabilities needed to run the zero tolerance, security, scalability, automation, the visibility of everything that needs to go on in this particular environment, and bringing the public cloud and the private cloud innovations together with those use cases that we've defined and we've been working with in terms of operators around the telco edge clouds. And as you can see from this diagram here, as over time, we've been able to now deploy telco core 5G based infrastructures in the core of the network. We've been working at the telco edge, and we're now working very closely with a number of those partners and integrators you see at the last mile, all using a common platform called OpenShift. And as we actually eventually get to the customer edge, having a common platform allows telecommunications operators to scale and deliver services into the enterprise, and actually have the enterprise with mobile edge compute, MEC as it's sometimes called, co-locate, co-host applications and services at that far edge to deliver private 5G or private instances of next generation applications which are predominantly AI, ML and AR, augmented reality, machine learning and artificial intelligence based. So this is really what we're trying to do at Red Hat, to bring this alive and make sure that our platform is scalable, as I said, from core all the way up to the far edge into the enterprise, with all of the automation, the cloud native portability you need, and the operational elements that you need to maintain a network in this configuration, delivering carrier grade features in terms of availability, reliability and performance. So with that, I would like to thank everybody for your time today. I hope that was a good introduction in terms of where we see the market, how it's evolving, how we are playing from a Red Hat perspective, and that complete partner ecosystem that's really driving Open RAN today. Thank you very much.